Okay, for tonight's homework, I'm going to have you do these problems into your packet and then do them into your composition notebook and write a complete sentence for each. Alright, these problems right here are having you prove if these lengths make up a right triangle. Just make sure of the three lengths, the largest one, the biggest one, always goes in the spot in the Pythagorean theorem by itself. The two smaller legs, or the two smaller numbers, can go in these positions in any order. You could switch these around if you want. You could have put 12 here and 5 here, but you cannot switch the big number. The biggest number, which we call the hypotenuse, has to go by itself over here in that part of the formula. So when I do 9, 40, and 41, 41 is my biggest number. That's the number I'm going to put into this part right here, into the Pythagorean theorem, to see if it works. So to see if it works, that will be 9 squared plus 40 squared. See if that equals 41 squared. 9 squared is 81. 40 squared is 1600. And again, I expect to use a calculator on this if you like. And that is a true statement. Those prove the Pythagorean theorem works, which proves that those lengths make up a right triangle. That triangle will have a right angle in there, guaranteed. Alright, next problem. This is the 3, 4, 5 triangle, one that you should memorize. 3, 4, 5 always makes up the sides of a right triangle. 3 and 4 are the two legs, so I will put those together. So 3 squared plus 4 squared, and again, I could have wrote that 4 squared plus 3 squared if I wanted to. I just have to make sure I put that 5 all by itself. So that gives me 9 plus 16, 25 equals 25. Those lengths make up a right triangle. I expect you to memorize those. 3, 4, 5 always make up a right triangle. Memorize those. Alright, next one. 6, 7, 8. Not quite as lucky. Will not work. That is 6 squared plus 7 squared equal 8 squared. That gives me 36 plus 49. And that will not equal 64. 36 plus 49 equal 85. And that is not equal to 64. So those do not make up a right triangle. That is a no. Alright, next, 20, 21, 29. Again, the 20 and the 21 are the two shorter lengths, so those are the legs. You put those together. You could flip-flop those orders if you want, but you have to make sure the 29, the biggest side, the hypotenuse, goes by itself. 20 squared is 400. 21 squared is 441. We'll see if that equals 29 squared, which is 841. And it looks like that will make up a right triangle. 400 plus 441 adds up to get 841. So that proves those lengths work in the Pythagorean theorem, and that proves those lengths make up a right triangle. That triangle will have a right angle in there, guaranteed. All right, next problem, 9, 12, 15. So 9 squared plus 12 squared, did that equal 15 squared? 9 squared is 81. 12 squared is 144. Does that equal 15 squared? 81 plus 144. Give me 225. Yes, that is a right triangle. That is one we'd like you to know, but not one we'd like you to memorize. The two we'd like you to memorize: 3, 4, 5 triangle, and then the one for number 7, 6, 8, 10. Memorize those. Alright, 10, 11, 15. Let's see if those make up a right triangle. So 10 squared plus 11 squared. See if that equals 15 squared. That gives me 100 plus 121. 15 squared, I believe, is 225. 100 plus 121, give me 221, and that is not equal. So those do not make up a right triangle. That is a no. That triangle does not have a right angle in it. All right, 6, 8, 10 triangle. Again, memorize that. 3, 4, 5, 6, 8, 10. Guaranteed right triangle, always. 6 squared is 36. 8 squared is 64. 10 squared is 100. 36 plus 64 gives me 100. That is a true statement. That is a yes. Shrink that down. All right, 8, 15, 17. So 8 squared plus 15 squared, does that equal 17 squared? 8 squared is 64, and I'm not sure why I put 36 right there. So those of you doing your homework tonight, make sure don't write 36 right there. I'm not sure what I did. That is 64. If I add 64 to 225, that gives me 289. So please, on this problem, fix this. This is 64. 64 plus this 225, give me 289. That is a yes. So I'll be checking in your homework tomorrow to see if you really watched my video, because that is not true. This should be 289. That is a yes. So please fix that. Shows you I am human and I do make mistakes like you guys. I will move on from it. Not going to beat myself up over it. All right, the last 3, and you will be dealing with some fractions, so good luck. To review substitution, when the variable has one of them solved, or one of the equations is solved for either x or y, that variable by itself tells you where in the other equation you're going to substitute, right here. This tells me what I'm going to take and plug right there. At first I make a little mistake here, but then I will fix it. So I'm showing the wrong substitution there. You're not going to plug into the other equations x. So I will fix this. I'm not sure why I did that. Again, you know, humans make mistakes. I'm going to fix that. So I see that, oh, I'm not going to substitute there. So to fix that, I'm going to take x plus 1 and substitute it into the other equation's y. So here we go. This is the legit way. That gives me the x is still there, the 2 is still there, but where that y used to be, I substitute that x plus 1 inside there. I will have to distribute that 2 and combine like terms. So 2x, 2 times x is 2x, 2 times 1 is 2. That gives me x plus 2x plus 2 equal 8. When I combine like terms, that gives me 3x plus 2 equal 8. I'm going to show the work up here. 3x plus 2. So now when I solve this, I'm going to take away 2 on both sides. That gives me 3x equals 6. Divide by 3 right here. Gives me x equals 2. Remember, that is only half my answer. I have to take that 2, plug it in right here to find out what my y is. So if I take that 2 and replace it right here for x, you'll see that y equals 2 plus 1. And then 2 plus 1, again, I'm showing you where I'm substituting that in. Gives me y equals 3. They want you to check your solutions. That point, or that solution, that system is x is 2, y is 3. So to do the check, I'm going to take that 2 and 3 and plug it into x and y into both equations and see if I get true equations, true statements. So I plug in 3 for y equals, where x used to be, I plug in 2. And that plus 1 is still there. That should give me a true statement. 3 does equal 3. And then when I plug 2, 3 into the second equation, should give me 8. So 2 plus 2 times the 3 right there where that y used to be equal to 8. And that gives me 2 plus 6 And yes, that is 8. 8 equals 8. That is a true statement. I'm going to rearrange this a little bit so I have more room, so bear with me. I'm going to shrink this down. I'm going to group all this work so I can move it and have more space. Expanding this up so I could see my next two problems. Alright, so for number 10, the equation by itself is this x. So that tells me I'm going to take this 3 plus y and substitute right into x in the other equation right there. So again, that variable by itself tells you where in the other equation you're going to substitute right here. This tells you what you're taking and substituting right there. So when I write that, it will be y plus 2, and where that x used to be will be this 3 plus y. So here we go. So when I substitute, I get y equals 2. I'm sorry, y plus 2, and where that x used to be, I substitute 3 plus y, and equals 7. I'm going to have to distribute right there 2 times the 3, 2 times the y, and then I will have to combine like terms. So y plus 6 plus 2y equals 7. Combine my like terms right there. That will give me 3y plus 6 equals 7. Take away 6 on both sides. Gives me 3y equal to 1. Divide both sides by 3. That gives me y equals 1/3. Now I need to find out what x is. To find x, I'm going to take that 1/3 and substitute right in here. I did mix the order up, but that's okay. I'm writing the 1/3 first and the 3 second. That is fine. So I get x equals 3 and 1/3. I expect you to know how to mix this fraction up. To mix this, 3 times 3 plus 1. That's how you mix a fraction. You will get 10/3 out of that. So now when I do my check, I will have to mix that fraction up for x, and I will have to plug in 1/3 for y. So here I go. Here is my check. So where y used to be, I'm going to plug in 1/3. I got that 2 there. Where x used to be, I plug in 3 and 1/3. I'm going to mix that up into 10/3. So I'll be able to multiply this 2 right there. To multiply a 2 times that 10/3, remember you put that 2 over 1, multiply straight across. 20 times 2 times 10 is 20. This 1 down here times 3 is 3. And you'll see you'll get 21/3, and 21/3 is 7. So that one does work. Good luck. Fractions are fun, aren't they? Alright, next I'm going to plug in 3 and 1/3 and 1/3 into the other equation to see if that works. So where x is, I plug in 3 and 1/3. Now I'm going to mix it up into 10/3. Remember that is equivalent to 3 and 1/3. Equal to 3 plus 1/3 where y used to be. And you'll see that 10/3 does equal 3 and 1/3. So yes, those are equal, and if I mix that up, I will see those are equivalent, so that check does work. Alright, last one, which has even gnarlier fractions, so good luck. I don't expect you to have to do number 12, but you could. I'm not in that, having that in the homework, but feel free if you'd like to try. So 11, this 9 plus 2y is going to substitute right in here for x. So 9 plus 2y into x in the other equation. So I'm going to have that 3 there still, but where x used to be, I plug in 9 plus 2y. I will have to distribute that 3 and combine my y terms with that 5y over here to equal 20. That gives me 3 times 9, which is 27. 3 times 2y is 6y, so that gives me 27 plus 6y plus 5y equal to 20. Combine my 6y and my 5y to get 27 plus 11y equal to 20. Subtract 27 on both sides, and that gives me 11y equal to negative 7. Divide both sides by 11, and I get the yucky fraction y equals negative 7/11. So to find x, I'm going to take negative 7/11 and plug it in right here. So x will equal 9 plus 2. And where that y used to be, I'm going to substitute negative 7/11. So 9 plus 2. Here goes the negative 7/11. I'm going to put that 2 over 1, multiply straight across, and get negative 14 over 11. When I take 9 over 1, I need to make 9 over 1 an equivalent fraction. So I need my denominator to have 11. So I'm going to multiply this fraction top and bottom by 11, which will turn that into an equivalent fraction. So when I multiply top and bottom by 11, I will get 99 over 11. That is 9 in disguise. I just changed it into that so I could subtract 14/11 from it. Common denominator. 99 minus 14 gives me 85 over 11. 85/11. So my point is 85 over 11 for x and negative 7 over 11 for y. When I do my check, yes, I am going to substitute those fractions in. You should be able to do fractions without a calculator. Alright, when I substitute that into the equation, so here we go. I'm going to substitute 85/11 in for x. I have that 9 right there. I have my 2 still, and where y is, I substitute negative 7 over 11. I'm going to multiply that by 2, which is going to give me 9 minus 14/11. I'm going to change that 9 into equivalent fraction over 11. So multiply top and bottom by 11 and 11 gives me 99 over 11, which is 9 in disguise. So 99 over 11 minus 14 over 11 gives me 85/11. So that is true for that equation. Now I'm going to substitute that into the second one. So here we go. Good luck. I will have to distribute times 2 fractions, or multiply. So here we go. Alright, so I'm going to have 3, and where that x used to be, I'm going to plug in 85 over 11 plus 5, and where y used to be, I'm going to plug in negative 7 over 11 equal to 20. 3 over 1 times 85 or 11ths. I will put that and multiply straight across. 3 times 85 gives me 255. 11 times 1 just gives me 11. 5 over 1 times that negative 7/11 will give me straight across negative. I'm going to change that. 5 times negative 7 is minus 35/11. I'm going to change 20 over 1 over here to an equivalent fraction over 11. So times top and bottom by 11 and 11 will give me 20 times 11, which is 220. And believe it or not, 220 over 11 is 20 in disguise. This is equivalent to 20. The only reason I did this is to make it so I have something to compare to. So 255 minus 35 gives me 220 over 11, and that is a true statement. Good luck.